All right, guys. So here we go. So yesterday, your job was to do this worksheet, and if you had issues with it, you were to go back and watch the video. So I do know some of you probably didn't do that, but just remember, I'm not going to listen to you guys say, "Oh, I didn't know, I didn't know." You guys chose to just sit on your phones. I already got the sub notes, so just make sure you, and I can't spell accepted very good, but just make sure you understand that your choice was not to do anything. So make sure you go back and do that. So. Uh, so let's tackle today's stuff. We're going to tackle solving inequalities, the logarithms. A review for that is on an inequality sign. Let's say we have like 2x is less than 8. And if I divide by 2, I get x is less than 4. That's kind of the idea, but you have to watch out because if you reverse your inequality sign here, that means you would divide by a negative. So if I kind of get rid of that piece and I say negative 2x is less than 8, when I divide by this negative, I get x is greater than negative 4. Okay? You kind of see what I'm talking about there. So now we get x is greater than, I don't want to write that there. So when you reverse the inequality, when you divide by a negative number. So watch out, that one. The inside of a logarithm must always be kind of like an x plus x minus h issue, okay? But it also must always be your domain. And since we're dealing with this and we know what these graphs look like, so it's got to be the domain. It must always be the domain. It's always x minus h, and it's always x is greater than 0. It's always positive. Always positive. Okay? That's a huge piece for us. And I'll show you why here in a second. So, when we're dealing with this, let's just disregard the inequality right now. So let's just take log base 3 of x. Let's graph that real quick. We know that this thing is at 1 and 0 and 3 and 1. It's up here like that, right? That's the idea behind it. And we have this idea that it looks like that. And we know from its domain, it can't go past this red line that I'm drawing right here at 0. So we know that x has to be greater than 0. So what we're saying is that all the x values have to be greater than 0. So let's go ahead and look at this. Let's solve this. So I have log base 3 of x, and that's going to be greater than 4. So how do I get rid of log base 3? I use base 3. Those are going to cancel. And I'm going to get x is greater than 3 to the 4th power. And that means x is greater than 81. So if x is greater than 81, so that means all x values are greater than 81. Does this one work? Yes. X can be greater than 81 because all x values have to be greater than 0. So let's take the next one here. So let's look at this. We know, let's just look at our base logarithm. Our base logarithm, looks like this. So it's a base 2, so it's 1 here, and we go over 2 and up 1. And we draw right here, right? And then we say, okay, well, I know for a fact, because my asymptote's right here, that x has to be greater than 0. Okay? You guys okay with that? Just shake your head yes for me. All right, cool. Now, so since we know what x has to be greater than 0, I can solve this equation. So I've got log base 2 of x is less than 4. How do I solve this logarithm equation? We're disregarding this inequality right now. Just solve it like an equation. So I have to use base 2. Base 2 of this side, it's inverse operation, so I'm left with an x, and then less than 2 to the 4th power. And then 2 to the 4th power is x is less than 16. Now we did this last semester, so if I look at this on a number line, or here, I know, let's just look at it here. I know that x has to be greater than 0 and it's pointing this way. But if I look at this x value, it's at 16, right? But it says it has to be pointing this way. So if I look at this, this keeps going, but it's got to stop at 16 because it tells me to stop at 16. And this goes to 0, and it can't go any farther than 0 because this tells me to stop at 0. So when I've got one pointing to the right and one pointing to the left, that means x has to be in between them both. So my answer is going to be 0 to x to 16. So x is going to be bigger than 0. 0 is less than x. And then x has to be less than 16. X is less than 16. Okay? And if you kind of look at this right here, it's just the reverse idea of that. 0 is less than x, and x is less than 16. In other words, it's in the middle. X is in the middle. Okay? All right. So, let's look at this one here. Same idea. We know that this has a asymptote right here. We know that x has to be greater than 0. 1, and I'm going to go over to 4 and 1. This is what my base graph looks like. So I know I'm looking for anything greater than 0. So log base 4 of x is greater than 3 for x is greater than 4 to the 3rd power. X is greater than or equal to 64. Is that going to be stopped by this at all? No, so that's my answer. Okay? All right. So now we come to the final type of problem. And we have some small issue here. So let's graph it first. Disregard this 5 over here. We're just going to graph this base idea. Okay? So I'm going to come over here and I'm going to draw my graph. And this tells us that this thing's going to move to the left 3. Remember, it's always the opposite. So we're going to move this thing left 3. So now my asymptote is over here, like this. And so I know that x has to be greater than negative 3. And then I move this over 3, and my graph looks something like this. So I know that all my answers I get have to be greater than negative 3. So let's go ahead and tackle this here real quick. So we have the natural log of x plus 3 is less than 5. So now, I'm looking at this and go, oh, what's my inverse operation? Remember, logarithms and natural logs and base e are inverses. So I base e to the left side, which gives me x plus 3, is less than e to the 5th power. And then I'm looking at this going, okay, I got to solve for x. X is less than negative 3 plus e to the 5th power. So now I've got this idea that this one is over here somewhere. It's, I mean, if you go 3 to the 5th power, it's actually way out here. Because remember, e is 2.71, and 3 to the 5th power, if you do 3 to the 5th power in your calculator, that's going to be like 243. So we're way out here at like 240, but I'll just draw it right here for now. So that means Actually, I'm going to go a little bit less than that. I'll come out here because we're way out here at approximately 240. Okay, so that says, this statement here says x is less than approximately 240. You can check your calculator. You can leave it like this. I'm going to. But I'm way out here, and this tells me that I have everything to the left, but I have to stop right there because this tells me that I have to have everything greater than -3, and it stops right there. So if they stop, that means x is in between them, and I get -3 is less than my value of x, which is less than -3 plus e to the 5th. That's my answer. Because we have to honor the fact that the natural log graph can't go below -3. So when they're less thans, we're going to get some value that looks like this. And when they're greater thans right now, we're going to get some value that looks like this. So really pay attention to the less thans. All right, that's it for today, guys. Good luck to you, and should be back tomorrow. There will be small weekly. Talk to you later. If I could actually turn this off. Yes, I want to end recording. What happened? Oh, I know what happened. What? Try that one more time. Look at that, I'm messing